Hello all. Welcome back to this series of JavaScript object-oriented programming techniques. This is the sixth part of it. And in the first 5 sessions we have addressed how to use the object-oriented features, how to achieve object-oriented techniques using the features provided by JavaScript. So in this particular session we will be looking at how to build up an application architecture at the enterprise level using the object-oriented techniques that we have learned until now. So the problem that we face in many of the applications and many of the web applications today is that we don't consider the JavaScript libraries that we have been using, like the jQuery, the prototype, the MooTools, the Dojo or anything, as a toolbox. We tightly couple our application to the JavaScript library. Such that if tomorrow there is another API that is in place, we cannot go ahead and easily change it. We will have to resolve to many changes in our application code to finally achieve the same. So this architecture is going to address those kind of solutions such that we don't have to be tightly coupled to the underlying JavaScript library. So this is a small snapshot of the architecture that I'm about to discuss on. Here the base library stands for the base library like jQuery, prototype, MooTools, or Dojo. You create an application core over it to address to provide an API such that which covers the base library. Like tomorrow, if you have to change from jQuery to prototype or from prototype to MooTools, only your application core component will be changed. Your rest of the pieces in your application architecture will work as is. There will be no impact to those rest of the pieces in your application architecture. So let us discuss each one of them in this architecture one by one. Okay, so the rules of the modules, that is module 1, module 2, module 3, module 4 are, they should not call or interact with other modules. That is the first rule. Only call your own methods or of the sandbox. The sandbox in this case should act like the mediator between the modules. Module 1 should not refer to module 2's code directly. It should refer through the sandbox. So that what happens is we can test module 1 or module 2 individually. Sandbox will act as a mediator between these modules. So don't access the DOM elements outside of your box. Don't access non-native global objects. Non-native basically means anything other than the date object array like window document. Don't create global objects. So the module should not create the global objects and keep it aside, because other modules may be impacted, or other JavaScript code which is out of any of the module will be impacted through it if there is a name collision. So let us look at a small snippet of code that will tell us how exactly our modules would look like. So in this case I have a small snippet of code Your core refers to the application core component of this snapshot, and I'll come back to the implementation of this module later. So we pass the module's name as the first parameter to register it into the application core, and then we pass the function which has the complete definition of the module. To that function we also pass the sandbox objects which each module needs in order to communicate with the rest of the world, because a given module is aware of only its own code and its own API, and sandbox to interact with the rest of the world. Now let us take a look on sandbox rules. The rules that it makes are, it has to provide a consistent interface to all the modules in this framework. Module 1, Module 2, Module 3, Module 4 should have a common API to interact with sandbox, to interact and get details out of the other modules. So that is one of the rules for sandbox. Security, it should not allow unwanted calls from the modules. And communication, sandboxes allow modules to communicate with each other through mediator pattern and not observer pattern. So in this case particularly we are discussing about sandbox as a communicator between the modules. It has to achieve it through the mediator pattern and not observer pattern. The reason for this is mediator pattern is a pattern which gives an event-based producer-consumer approach. That is not the case with the observer pattern. In observer pattern, each and every module needs to be aware of each other module that it wants to listen to. So let us take a look at the code snippet of this. So in the case of, in the default case, if we have module 1, module 2 and a common module, if there is a state change in the module, it will call the common module's particular method to inform it about the change in the status. Same is the case with the module 2, that it has to inform the common module about its change. This is tightly coupled architecture wherein both the module 1 and module 2 needs to be aware of the common module and its particular method. And tomorrow if there is any change in the method API itself or the change in the object's name itself, then it will result in the modification of both module 1 and module 2, though the actual change is only at the level of common module. So that is not the case with the module with the mediator pattern. We have a module 1 which informs sandbox about its change in status. Same is the case with the module 2 which informs the sandbox about its state and change in status. And your common module registers with the sandbox for the events that it wants to, and there will be a callback function whenever there is there has been such an event that is occurring, and the callback function further takes care of the particular method to be invoked on those events. So all these components, that is module 1, module 2 and common module, needs to be registered with your application core as the base object, to achieve decoupling. And in this case, you will see module 1 and module 2 need not be aware of the common module. So this happens to be the rules for the sandbox. Sandbox happens to be the most important part of this application architecture. It has to be designed very early, and it has to be designed with a lot of considerations in mind. Application core rules. So the application core rules, the responsibilities of it are: manage the module's lifecycle, general error handling, be extensible error handling, be extensible, and the features which comes under them are error handling, Ajax communication, new module capabilities, and general utilities. So let us take a look at the way the application core needs to be coded for. So this happens to be the application core. So we have already covered how to register a given module into the core. So when a register function is invoked, it registers the function into its own data collection to maintain the complete list of modules available with it. You have a start function and you have a stop function. You have a start all, stop all, managing the life cycle of the modules. And then you invoke the core.startAll to start all the modules to work. So this happens to be the application core's design. So as part of be extensible, especially the Ajax communication of it, this is one concept that needs to be addressed. So the three components that form the basis for the Ajax communication are the request format, the entry point, and the response format. And you will observe that for each and individual requests in every product, we will be having these three repeated. So what is the request format? Request format is nothing but the parameters that we pass for a given Ajax call. So which happens to be a query string. The second is the entry point. Entry point happens to be the URL or the resource that we are trying to access for. And this is hard-coded in all the places in our JavaScript that needs Ajax calls. And response format is the response of the server for your Ajax request, be it an XML, be it a JSON, all these forms as the response formats. So these three things will be repeated in every place an Ajax call is made. Your application core should be extensible enough to address these common issues and keep it at one place. That is your request format, which is a query string, has to be coded in one place, and your entry point, which is basically a URL that you hit for your Ajax calls, will be repeated, which will be repeated across all the modules. Those needs to be taken care in the extension module of the application core such that it is not repeated and it is easily maintainable. So hide the Ajax extension details. So the responsibilities of Ajax extension module in your application core are: hide your Ajax extension details. Ajax extension details refers to the entry point and the framework that is used, the underlying framework that is used to invoke the Ajax calls. Provide a common request interface the request format, and provide a common response interface, and then the manage server failures. So in this case, in depth we can think of the response interface as a server is responding with a JSON or XML, there has to be a common core component built in application core which takes care of avoiding this ambiguity of XML or JSON return string and providing the upper layers with a common interface for it to interact with the objects provided by your server. So these happens to be the responsibilities of the application core. Along with this is the major responsibility of hiding the underlying base library. So your base library, there are many tools that are available today: jQuery, Prototype, MooTools, Dojo, YUI. You need to use your JavaScript libraries as a scaffold. Scaffold meaning you can change it during the product development to any other framework, and you should still be able to run all those modules, the sandboxes as is. The only component that will change in your application architecture will be your application core component. So the responsibilities of the base library happens to be the browser normalization, which means if the same code is executed across all the browsers, the base library has to take care of the ambiguities or differences between the browsers, and it has to return you the expected functionality that is the same across all the browsers. So next we'll take a look at the other utility functions that has to be provided by the base library: the parsers or the serializers for XML, JSON, object manipulation, DOM manipulation, AJAX communication. All these happens to be the responsibilities of the base library, and it has to also provide extensible API such that if there is a need for us to change tomorrow with a new functionality which has to be provided by the base library, there has to be extensible features for this. Say browser's extension, in this case a specific code for a specific browser. So all this will come under the base library. So the advantages of using such an architecture is that majorly loose coupling is achieved because you can modify the various components of the architecture without being a major modification at the other modules of the architecture, and each part can be tested separately. So these are some of the advantages of this framework. So this happens to be the session or the best fit architecture for JavaScript applications. In the upcoming session we'll be addressing the optimizing techniques that can be used in JavaScript to improve the performance of the user experience across the browsers. Thank you.